learners, today we are going to look at a Form 2 mathematics topic by the name indices. Now before we can delve into the details about the topic indices, let's just look at some of the specific objectives. So by the end of the topic, the learner should be able to, number one, define indices or powers. Number two, state the laws of indices. And number three, apply the laws of indices in calculations. Now, in our introduction, I want us to understand what we mean by index and base form. The power to which a number is raised is called the index or indices in plural. Consider the following. 2 to the power 5. When we write 2 to the power 5, that's simply the same as 2 times 2 times 2 times 2 times 2, or you multiply 2 by itself 5 times. So in this case, 5 is called the power or the index, while 2 is the base. Now, when you write 100 equals 10 squared, what does that mean? This one simply means that in our case, 2 is the index and 10 is the base. Now let's look at the laws or the rules used in solving indices. So rule number one, any number except 0 whose index is 0 is always equal to 1. So what I mean is this: when I say 10 to the power 0, that means that is 1. I can give a real example. If I say, for example, that I'm going to give you 1 million to the power 0 shillings, what exactly do I mean? I mean that I'm going to give you 1 shilling. So anything to the power 0 is simply equal to 1 except 0. So 0 to the power 0 is not equal to 1. 8 to the power 0 equally would be equal to 1. Rule number 2. To multiply an expression with the same base, pick one of the bases and add the powers. Now, a to the power m times a to the power n must be equal to or is equal to a to the power m plus n. E.g., 2 squared times 2 to the power 3, that's the same as 2 raised to the power 2 plus 3, and that is simply 2 to the power 5. The next rule: to divide an expression with the same base, pick one of the bases and subtract the powers. We have seen for multiplication, we add the powers, but for division, we do the exact opposite. In this case, we shall subtract. So a to the power m divided by a to the power n must be equal to a to the power m minus n. For example, when you say 5 to the power 6 divided by 5 to the power 4, that's simply the same as 5 to the power 6 minus 4, and that is 5 squared. Rule number 4. To raise an expression to the nth index, copy the base and multiply the indices. So when you say a to the power m raised to the power n, that is the same as a to the power m times n. For example, 3 squared raised to the power 3 is the same as 3 raised to power 2 times 3, which is 3 to the power 6. And finally, rule number 5. When dealing with a negative power, you simply change the power to positive by changing it into a fraction with 1 as the numerator. So when you write a to the power minus m, you simply are going to write 1 over a to the power m. So when you write 1, you get the power. If it was a negative, then it becomes a positive. If it was a positive, then it becomes a negative. So you negate vice versa. So if I would have, for example, a to the power m, that's simply the same as 1 over a to the power minus m. You always negate the power. For example, when you write 8 to the power minus 3, that is the same as 1 over 8 to the power 3. Next, we are going to look at a few examples. Example number 1. So we're supposed to evaluate the following, and number A, 2 to power 6 times 2 to power 4. In this case, the solution, we have seen that when the bases are common and then we are multiplying, you just pick one of the bases. So that is going to be 2, and then you add the power. So that is going to be 6 plus 4, and that is 2 to power 10. All right. B, example number 2, if we are supposed to evaluate 3 to power 10 divided by 3 to power 6, what are we going to do? We are simply going to pick one of the bases, and in this case that is 3, and then because we are dividing, then for the powers we shall subtract. So that is simply 3 to power 10 minus 6, and that is 3 to power 4. I want us to look at another question where we're supposed to solve for x. So I want us to solve for x in the following: 2 to power x raised to power 3 equals 2 to power 12. Now, in this case, on the left hand side we have 2 to power x raised to power 3, and on the right hand side we have 2 raised to power 12. So what we shall do, because here it is 2 to power x and then again raised to power 3, we have seen in rule number 4, if that is the case, we simply multiply the power. So this is going to be 2 raised to power x times 3, which is 3x, and that should give us 2 raised to power 12. Now, what happens if the bases are the same and there's an equal sign? We drop the bases and then we equate the power. So this is going to be the same as 3x equals 12, and when we reach here we simply divide both sides by 3 to get the value of x as 4. So the value of x in that case is 4. When you're dealing with a negative number, you're told to evaluate, and can start with this kind of a question: 2 over 3 raised to power minus 2. So there's something that we have already said. When we reach a point where we are dealing with a negative power, we can simply introduce 1 over, and then the power will be negated. If it is a minus, of course it will be plus. And in this case, because it's minus 2, we shall end up with 2 power 2. So that is the same as 1 over 2 over 3 squared. We can simplify this. So this is the same as 1 over 2 squared is 4, and 3 squared is 9. So when we say 1 over a number, we are simply talking about its reciprocal. So 1 over 4 over 9 is just like simply reciprocating 4 over 9 to get 9 over 4. Next, I want us to look at problems on fractional indices. So when you're told, for example, to evaluate, you're told to evaluate 27 raised to power a third. What exactly do we mean? So whenever you encounter this kind of a question, we encourage students to do factorization. So we need to find or to express 27 in its simplest form in terms of prime factors. So when you have 27 using the factor method, that is simply 3 because of 9 and 3 because of 3. So instead of having 27, we shall simply have 3. How many times? 3 multiplied by itself 3 times, that means it's 3 cubed. So 27 is 3 cubed, but remember it is 27 raised to power a third. So instead of 27 raised to power a third, that is simply going to be 3 to power 3 raised to power a third. And we have seen again, when you raise a number, then you raise it again, you simply multiply the power. So this is simply going to be 3 times a third by 3 1 by 3 1. So the answer will simply be 3. So 27 raised to power a third is 3, or it's like finding the cube root of 27. So the cube root of 27, which is represented by a third, is 3. Now let's look at this other question, which requires us to evaluate 16 raised to power 3 over 4. Now, just like I've said, you need to express 16 in its simplest form in terms of its prime factors, and 16 is the same as 2 by 8. 8 is the same as 2 by 4, and 4 is the same as 2 by 2. So instead of writing 16, we shall write 2 to power 4. So instead of writing 16 to power 3 over 4, we shall write 2 to power 4, but then everything is to power 3 over 4. And when we reach this point, we shall multiply the power. So this is the same as 2 raised to power 4 times 3/4. Of course, by 4 1 by 4 1, so we shall end up with 2 cubed, which can further be simplified to give us 2 times 2 times 2, which is 8. Okay, let's have our last question for this lesson, and the question requires us to simplify, and the numbers we are trying to simplify in this case, I'm going to give you a long one, 2 to power minus 6 times 5 raised to power a half times 2 to power 7 divided by 2 to power minus 4. So that's a question. So in this case, we have the liberty to collect the like terms. So you can see that we have 2 there, 2 there, and 2 there. So we can collect the 2's to be under one base, and then where we have multiplication we add, and where we have division we subtract. So for the first 2, we are talking about minus 6. Then the second one is times 2 to power 7, so we shall add 7. And third, we have divide, so we shall subtract, so minus 4. And then that will be times 5 to power half. So we can actually simplify the power, so minus 6 plus 7, that is 1. 1 minus 4 is minus 3, so we shall end up with 2 to power minus 3 times 5 to power half. This can be simplified further. If the power is minus, you can just introduce 1 over, then you negate the power. If it is a minus, it's becomes a plus. In this case, it's a minus, so it shall be plus. And then multiplied by 5 to the power half. And we can put everything under 1. So this is simply 5 to the power half over 2 cubed. Over 2 cubed. All right. For your assignment, I want you to evaluate and simplify the following. So the first one is to find the numerical value of, so evaluate number A, 9 to the power half, B, 25 to the power minus a half, C, 35,769 to the power 0. Next, D, 10 to the power 3 raised to power 5 over 3. E, 64 raised to power minus 1 over 6. That one is for evaluation. And the next one, question 2, you're supposed to simplify the following. A, x squared times x power 4. B, a squared times b squared times a to the power 4. C, x squared y squared times x squared y to the power 5 times x to the power minus 3 y to the power minus 3. So try those two questions out, and when we meet next time, I'll give you the solutions. So that marks the end of our lesson today. Thank you very much for tuning in. See you next time.